Hello my dear students, welcome back to your channel of learning mathematics. In the last videos we discussed about cuboids and then we discussed about cylinders and of course cubes. There we discussed about the surface areas of cuboids. It had 6 surfaces, 4, 5 and 6, and similarly for cylinder also. This is a hollow cylinder, a pipe. If we assume it to be a pipe, then this will have only one surface, that's the curved surface area only. But for solid cylinders it will have 2 more surfaces, that's the circular base 1 and 2. There we have also seen how we find out the total surface area of a cuboid, where the surface areas of all the 6 surfaces, are calculated, which is called the total surface area. Similarly for cylinder also. And we also learned how do we find out the lateral surface area. Now lateral surface area in cuboid and in cylinder, it's actually the same only. Lateral surface area in cuboid, we call it lateral because its walls are, standing straight. It's straight, all these walls, the walls of a room. It has the same meaning for a cylinder also, but it's just that in a cylinder, this surface is actually curved. Even if we place it like this, it is actually curved. So that's why we call it curved surface area. Otherwise, it is same only, lateral surface area or curved surface area. It has the same meaning only. Curved surface area means this portion. Lateral means again the same, but lateral, we call it lateral because it is, standing straight. All right. Now, in this video, what we are going to do is we are going to be learning about cones. I have made a small cone for all of us. So we will be studying about cones and its surface areas. All right, so basically a cone looks like this, as we all know it. For example, like ice cream cones, traffic cones, right? There are also 2 types of cones. One is the hollow cone, which is empty like this. Basically, the ice cream cones, birthday caps, traffic cones. So here this is empty. And we have a solid cone, like basically that is made up of wood, iron, so it's going to be closed like this. All right, now if we look at the surface, then if we consider just a hollow cone like a ice cream cone, then it will have only one surface, that is only this part, this curved surface only this curved surface only. All right, and it will be called as curved surface area, or also known as I said, lateral surface area also. It has the same meaning, but we prefer to call it curved surface area. But don't be confused if it is called lateral surface area also. Lateral means standing straight. So in figures like cone, cylinder, we call it lateral curved surface area. So it will have only one surface. But if it is a solid cone like this, made of wood or iron, then it will have 2 surfaces. One surface is the curved surface area, the other surface will be the surface area of the circular base. This will be circular. Okay, this will be a circle base, so it's called a circular base. Then in that case we can find out the total surface area will be the curved surface area plus this area of the circular base. But if it is a cone, hollow cone like this, even if they say total surface area, you should read the question. It means only the curved surface area, because in a cone like this, an empty cone where it doesn't have any surface, total surface area or curved surface area, it's because there is only one surface only. All right, now if we look into the details, for example, if I draw a cone like this, then this tip, this is called the vertex of the cone. All right, and the circular part, the middle, this is the middle. If we consider, this will be the radius of the cone, radius of the circular base of the cone. This will be the perpendicular height, or we call it the perpendicular height, or also we also call it as the altitude. All right, perpendicular. And this height will be called as slant height. Why? Because it is slanting. It's this height, this one, this height, this height, no, this height, this height. This is called the slant height. So if I want to find the slant height, it's going to be this height, this line, if you can see, no? This is the slant height. All right, so if you place it like this, then I think this will be much better. So this is called the slant height. All right, and of course, yes, I forgot to mention that in class 9 we will be learning about right circular cone. Now what do we mean by right circular cone? It's nothing but like from the vertex, if you join the center of the base, circular base, then it should, if it makes an angle of 90 degree, then we call that as a right circular cone. Examples like this. So from the center, from this tip, if I draw a straight line to the center of the circle, then it will make a 90 degree. We have other types of cones also, like see, sometimes we can have a cone like this also, something like this. This is also a cone only, but if I join the vertex to the center, then it's definitely not going to make a 90 degree. It's going to make some other angle. So these are not examples of right circular cones. So in class 9 we will be dealing with ideal cones, right circular cones only. Okay, all right, now let's have a look at some of the formulas. That is okay, we have the radius of a cone denoted by r. We have the height, height, or altitude, that is denoted by h. I'll just write it here. This is r by radius, and slant height we denote it by l. There is a relation between slant height, radius and h also, because if we complete this circle, this is r, this is h, this is l, then we get a right angled triangle like this, isn't it? This is r, this is h, this is l. So if we use the Pythagoras theorem, then it is, then in that case slant height L square will be equal to h square plus r square. So this is one relation that we usually use in a cone, or L in short can also be written as root over of h square plus r square. Either way, either this or this. This is also useful sometimes, this is also useful sometimes. Okay, then in that case, now curved surface area of cone, which is also known as lateral surface area of cone, is given by pi into r into slant height. Total surface area of cone, if it is a solid like this, if I mentioned like this, closed, made of wood or iron, then in that case it will have two surfaces, that is curved surface area plus the circular base area. I'm just showing how we derive. So that is pi r l plus circular base areas. Area of circle is always what? Pi r square. So the formula will be pi r, if we take common, l plus r. I'm just showing you this just in case in the exams you forget the formula. You can derive it using this idea also. Alright, so these are the basic details about cone. Let us now straight away jump into the exercise. Zala, let's begin to solve the exercise. So the first question that comes up is exercise 13.3, question number 1, that says diameter of the base of a cone is 10.5 centimeters. So let's find out the radius. So if diameter is given, we know that radius is half of diameter, that is diameter divided by 2, that will be 10.5 divided by 2 centimeter. Let me just keep it like this. Slant height is given. Slant height L is given again to be 10 centimeter. So the question is very simple, find its curved surface area. So curved surface area of cone is pi into r into L. We'll use 22 by 7 for the value of pi. Radius is 10.5 by 2 centimeter into length is 10.5. So if we just divide this, 2 ones are 2, 2 11s are 22, 7 ones are 7, 7 ones are 7, 3 left, 0.35, 7 5s are 35. So what do we have? 11 into 1.5 into 10 centimeter square. So if you multiply this, 11 into 1.5 into 10, what do we have? 165 centimeter square. So this will be the curved surface area of a cone. Okay. All right. Second one. Find the total surface area of a cone if its slant height is 21 meter. So slant height L 21 meter. Again, diameter is given, so radius will be, I'm not writing diameter and all just to save some time. Radius will be half of diameter, so that's going to be 12 meter. So let's find out the total surface area. So total surface area of cone, let's use the formula directly, that is pi into r, L plus r. It's a good thing everything is given here. So 22 by 7 into radius is 12 meter into slant height 21 meter plus radius 12 meter. So I'll just multiply this because we can't cancel it, isn't it? So that's going to be 22 into 12. So that's going to be 264 by 7 into 21 plus 12. 21 plus 12, that will be 33 meter into meter square. So that again we'll have to multiply into 264. So that's going to be 8712 divided by 7 meter square. So that if we divide by 7, we will have 1244.57 meter square. Just to save some time, I'm just calculated it directly. Of course, you can divide it by the usual division method. I am sure that all of you are very familiar with division. All right. Okay. So you can pause the video if you have to note it down. Done. All right, let's move on to number 3. What is the question there? Curved surface area of a cone is 308 centimeter square. Slant height is 14 centimeter. So slant height L is given 14 centimeter. Find the radius of its base. So let us just write radius of base BR. What is given? Given curved surface area of cone 308 centimeter square. So what is the formula for curved surface area of a cone? That was pi into r into L. It's given that it is 308 centimeter square. So let's use the formula. 22 by 7 into radius. We have to find out slant height is 14 centimeter. That is equal to 308 centimeters square. So radius is missing, but to find out the missing radius, slant height is given. So if we cross multiply, 7 goes up, divided by 22 comes down, 14 also comes down, centimeter square, centimeter will come down, centimeter square, 1 centimeter cancels, 7 ones are 7, 7 twos are 14, 2 ones are 2, 254, so 22 7 times if I'm not mistaken. 22 into 7, 7 twos are 14, 1 left, 7 twos are 14, yes. So the radius of our cone is 7 centimeter. So that's the first solution. Second one, they say total surface area of the cone, no problem. So total surface area of the cone, pi r L plus r. So 22 by 7 into radius, we calculated how much, 7 centimeter, into slant height was 14 centimeter plus 7 centimeter. So that's 1717 cancels. So 22 into 14 plus 7, 21 centimeter into centimeter, that's centimeter square. So how much will that be? 22 into 21. So that's going to be 462 centimeter square. That's the total surface area of the cone. Okay. All right, moving on. Chalo. Let's move on to this one. I have to write down. So question number 4, that is a conical tent is 10 meter high, and the radius of its base is 24 meter. Find number 1, slant height of the tent. I'll just write down the first question. Second question we will do again. So what they have given us is there is a conical tent, a tent in the shape of a cone. It's given that the altitude or the height of the cone is 10 meter, radius of its base is 24 meter. Question is, what is the slant height, L? I give you the relation, that is, we know that slant height is equal to root over of square of the sum of the squares of height and radius. So let's calculate this. So that's going to be, what is height given? 10 meter whole square plus radius 24 meter whole square. So 10 meter, that's 100 meter square, 24 square, that's 576 meters square. So that's going to be root over of 676 meters square. So what is the square root of 676? That is, if I'm not mistaken, that is 26 into 26 meters square. So that's going to be 26 meter. All right, so that is the slant height of the tent. Okay. Of course, you can calculate. Let me just show you 676. You can do it by long division method or factorization method also. Let us do by factorization method. So let's let 2 3s are 6, 2 3s are 6, 2 8, 2 1s are 2, 1 left, 13, 2 6 are 12, 1 left, 2 9s are 18. This is 169 is 13 into 13. So our square root will be 13 2. So that's 13 into 2, that is 26. Second question, second part I mean, find the cost of the canvas required to make the tent. If the cost of 1 meter square canvas is rupees 70. Canvas means to the cloth, yeah, something like a cloth to cover the tent. So see, if you have a tent like this that is placed on the ground, then you will be needing the cloth to cover the tent only on the curved surface part only. Definitely you're not going to cover the floor, isn't it? If your tent is like this, then how are you supposed to enter, right? So usually we do not need, we may use mat and all, something like that, but we just need to make the tent, we just need to place it on the curved surface area only, curved surface of the cone only. Now, so we will find out the curved surface area of the cone, and then from there we will find out how much will it cost us to buy the canvas. For 1 meter square it is given rupees 70. So for that we will find out the curved surface area of the cone, that is pi into r into L. So that is 22 by 7 into radius. How much was it radius? Okay, 24 meter and 26 meter. So that's 22 into 24 into 26 by 7 meter square. They haven't told us to find out the curved surface area indirectly. Our main priority is to find out the cost only. So we'll keep it like this. We'll not waste time calculating. Okay. Cost of 1 meter square canvas is how much? Rupees 70. So how much meter square do we have? This much meter square. Like cost of 1 meter square is 70. So cost of 2 meter square will be 2 into 70. 3 into 70 and so on. So we have this much meter square of cloth required to make the tent. So total cost of canvas will be rupees 70 into how much meter square do we need? This much, 22 into 24 into 26 by 7. So 7 tens are 70. So total cost will be rupees 10 into 22 into 24 into 26. That will be how much rupees? Let's calculate this. So 22 into 24 into 26, that's going to be rupees 137280. So it's going to cost you 1,37,280 rupees. Fine. So that's up to question number 4. Remaining questions we will do in the second part of the video. Alright, so please go through it. I'll see you in the next video. Okay, bye bye.